How many biological parents do you have? Yeah, two, that's right. It's the number two, and there's no exception to that rule. Everyone has two biological parents. There are some bizarre situations where there could be some other thing going on, but in general, it's two. How many biological grandparents do you have? Four-ish. It's four. Four. How many biological great-grandparents do you have? Seven or eight. Yeah, because, cousins, The number of ancestors you have as you go back by generation ought to be the number of powers of two. It ought to be a power of two. But because of this cousin factor, it begins to shrink. So as you go back further and further in time, the number of ancestors in your family tree gets much smaller than a power of two. So if you go back 10 generations, for example, you could have as many as 1024 ancestors, but you very probably have far less than that, probably less than 100. Most people tend to live in the same area. Their families tend to live in the same area. You lose track of cousins after a generation or two. So who knows, right? There could be all kinds of crossed lines. So let's assume that a generation is, 20, 10, power of 10. How am I thinking this? Let's go back 10 generations. 10 generations is 200 years. Roughly. And so that would be what, 1819. And you have 1,000 possible ancestors, but you don't really have that many. Let's go back 400 years, 20 generations. You have 1 million possible ancestors. 2 to the 20th is roughly a million. You have 1 million possible ancestors. The year is 1619. Probably, though, you don't have 1 million back there at all. You probably have a very small number, maybe a few hundred. Let's go back another 10 generations. Now the year is 1419. Columbus has not yet sailed. You have 1 billion possible ancestors, 2 to the 30th. But there were probably not 1 billion people on the planet. Go back another 10 generations. The year is now 1219. The Magna Carta was signed 4 years ago. You have 1 trillion possible ancestors. There have never been 1 trillion human beings, ever, including all the dead ones. So clearly this does not go by powers of two. It somehow starts out as powers of two, and then it starts to curve inwards. And then the question is, does it go parallel, or does it really curve inwards? As you go back in time, do the number of ancestors begin to decrease? And the answer to that is yes. The number of ancestors begin to decrease. And this becomes clear when you realize that if you go back far enough in time, there may be a lot of people alive back then, but their lines have a positive probability of dying out. And so you can go back far enough so that only one line has not died out, the line that you happen to be on. And that's a reasonable proof to suggest that if you go back far enough in time, you will find one man and one woman who is the source of your genetic material. All of your ancestors go back down to 2. So our ancestors grow by powers of 2, and then they shrink, and then they head back in, and they go right back down to 2. And that's interesting. Now, we could do that analysis for everybody in the room. And we'd have to go back further in time, but if we did, we would find that for everyone in the room, there was a single common mother and father. 2 people somewhere in the distant past who were the source of the genetic information for everyone in the room. These 2 people did not know each other. They probably didn't live within 100 years of each other or even 100 miles of each other, but it's a mathematical certainty that they existed. We could do this analysis for the entire planet and find the mother and father of everyone alive today, the Adam and Eve of everyone alive today. And this is just a mathematical certainty. These people existed. Is there anything we can learn about them? Well, it turns out there is. Because most of our genes are mixed all up together with all kinds of, meiosis is a messy process. We cut the genes up and we mix them together. There's no good way to tease apart the genetic pathway to the original Adam and Eve. But there is a strand of DNA within your bodies that you only get from your mother. It's called the mitochondrial DNA, not midichlorians. Mitochondria. And the mitochondrial DNA lives in a little organelle within your cells called the mitochondria. It's not in your nucleus, it's in the mitochondria. And egg cells have mitochondria and sperm cells don't. So you only get this strand of DNA from your mother, who got it from her mother, who got it from her mother, all the way back to the mitochondrial Eve. Now, we know, roughly, the rate at which these molecules mutate. So we could compare each other's mitochondrial DNA. And if two individuals had identical mitochondrial DNA, then you would expect that they had a common mother very recently. But if there were one or two differences, you would expect that, maybe there's a mitochondrial mother, sometimes slightly further in the past. And if there were many differences, well, then you'd expect that to be very far in the past. And we can do the analysis on the entire human race. We do it statistically, of course. And we calculate the number of differences. We know the rate of mutation. And we wind up with a fascinating number. Mitochondrial Eve lived about 150,000 years ago. That's not a very long time when you think about it. Right? 150,000 years ago. Now, it happened to be in an interesting time geologically. It was during the warm period before the last glaciation. So mitochondrial Eve lived in a pretty good time. We know where she lived. She lived in the east of Africa. We know that because that's where the most mitochondrial diversity is. We know the path, the migrations that her children took. We can see cohorts moving. Just in the genetic information itself, we can see cohorts moving north and to the west into Europe, and a completely different cohort moving to the north and to the east into Asia, and a completely different cohort walking around the Pacific Rim, around India and down into Indonesia. All of those things we can see. We can see a cohort crossing over the Bering Straits at 14,000 years ago, entering North America and getting to the tip of South America within 1,000 years. All of that stuff we can see. Men in the room, you have a strand of DNA that only comes from your father. It's a Y chromosome. Y chromosome does not mix during meiosis. It's a pure strand of Y that comes from your father, who got it from his father, who got it from his father. So the exact same analysis can be done on the Y chromosome. And we find that the Y chromosome Adam lived 70,000 years ago at the height of the last glaciation in the east of Africa. And we can trace the migrations of his sons. Can't see anything about the daughters, but we can see the sons. And we can see how they migrated around the planet. And the migration patterns are eerily similar, but oddly different from Eve's patterns. Anyway, it's a fantastic amount of information we can get out of just the molecules within our body. And it leads to fascinating counterintuitive results, which of course is not what we're supposed to be talking about. What are we supposed to be talking about? Well, this particular talk that I'm going to do is on professionalism. This is one of my favorite talks. I do it all the time because in this talk I get to pretend I should plug in the screen. Up. It's there. It's there. I get to pretend that I am your new CTO. You do not want me to be your new CTO. I would not be a good one. I'm not a great administrator. I hate the whole process of administrating things. I hate all the politics. I would much rather bury my brain in code and be on stage. I like being on stage, and I like writing code. It's a very strange personality defect of mine. In any case, you don't want me to be your new CTO, but if I were your new CTO, I would have expectations of you. And I'm going to define those expectations for you over the next hour or so. When you hear these expectations, you will hear them with two ears. One ear will be the ear of the programmer. The other ear will be the ear of everyone else in the world. The programming ear is going to hear insanity. The everybody else in the world ear is going to hear perfect sense. Why is this important? Well, I made the case a little earlier today about why we need ethics and why we need a moral standard and why we need a profession. So this is to talk about what those standards might be, what that profession, what we might profess within our profession. But before we do that, we should talk about one other thing. I mentioned earlier about how many computers were in the room. How many programmers are there in the world? 16 million. Good number. Where'd you get that number? No. You read it? Oh, yeah? 16 million? I don't know if it's 16 million. Maybe it is. I rather think it's larger, but of course it depends on whether you count the VBA programmers. The number I like to use is 100 million. Could there be 100 million programmers in the world today? Is that possible? Okay, well that's what? 10 to the 8th. 10 to the 8th programmers in the world. How many programmers were there in 1946? One, Alan Turing. First guy to write a program to execute on an electronic computer was Alan Turing. And that was 73 years ago. So we went from 1 to 100 million in 73 years. Now, what kind of growth curve is that? Is it linear? It's not linear. It's exponential. It's an exponential curve. Yeah, this one, right? Goes like that. And if it's an exponential curve, then it has a doubling rate, because every exponential curve could be an exponent of 2. So we're going to say, okay, it's a doubling rate. Well, how many doublings does it take to get from 1 to 100 million? It's not too hard to calculate. 2 to the 20th is 1 million. 2 to the 7th is about 100. So right around 2 to the 27th. Okay. Well, so there's 27 doublings between 1946 and now. Well, okay. What's the distance between the doubling? How much time between doublings? 73 divided by 26 is 2 and something? 2.9, 2.8? Does the number of programmers in the world double every 2.8 years? Is that possible? Now, hang on. That first decade, they probably doubled a lot faster than that because, in 1946, Alan Turing was the first programmer, but the next day there were 10. And a few days after that, there were 30, right? But the doubling rate probably slowed down about 10 years later. So we might guess that the doubling rate of programmers in the world is something on the order of 5 years. And there is actually a substantial amount of data to suggest that the doubling rate of programmers in the world is roughly every 5 years. The number of programmers in the world doubles every 5 years. That's unbelievable. That's a crazy rate of increase. And it has deep implications. And one of those implications is that half the programmers in the world have less than 5 years' experience. And as long as we are doubling at a rate like this, half the programmers in the world will have less than 5 years' experience. We won't be able to escape from that, which leaves our industry in a state of perpetual inexperience. A lot of people look around at programmers and say, well, they're all young. Right? So that's a young person's game. Old people shouldn't be bothered with it. Where'd all the old people go? We're all still here. There just weren't very many of us back then. Right? It's not like all the old people disappeared or anything like that. It's just that, hordes and hordes of 20-year-olds have been pouring into this field for the last 30 years, and all the old people are going, whoa, a lot of young kids around here. Wish they'd get off my grass. Who has been gathering the body of knowledge in our field? Where has the experience gone? The experience clusters in a relatively small number of programmers who have been doing this for a few decades. But there aren't very many programmers who have been doing this for a few decades. Half the programmers in the world have been doing it for 5 years or less. A quarter of the programmers in the world have been doing it for more than 10 years. That's the level of inexperience that we all face. How do we get the information out that's been learned by all these old dudes? How do we get that out to all the young people who are pouring in and who believe they already know how to write code? Write a book. I can write a book. I can write a book. You can write a book. You think they're going to read it? Who teaches them? Professors? Professors in college? Professors in college are 10 years behind. Most professors in college who teach programming never wrote a line of code for pay in their life. Right? And the universities are turning out people who are woefully unprepared for what they face once they get a job. Did anybody get the shock of reality when you got your first job and thought, gee, this isn't like school? How do we instill within programmers the knowledge and the desire to profess a set of ethics? And one way might be to have expectations. So here are the expectations I have of your new CTO. My first expectation is we will not ship shit. Now, I know the programmer ear is already going, that's insane. We have to ship shit. There's no way around it. I mean, what do you want us to do? Actually make the code work? But the rest of the world, the other ear, is going, well, yeah. I mean, what, you mean you're shipping shit? This is the first thing we have to overcome. And I realize that the phrase is a little bit over the top, but I want you to think about what has happened over the last 30 years. Do you realize that people now regularly download betas? You understand what a beta test is? Right? A beta test is when you carefully select a few trusted users and you tell those users, all hell's going to break loose when you use this code. Please be careful, but it would really help us if you used this code to feed us back. And now, of course, we just let people download them. Yep, it's beta. Tough bananas, boys. And you know what? We're never uploading anything but betas. It's going to be betas from now on. This is the attitude of people who are uploading code into the internet. Do you believe that code must have bugs? Be careful. Because you know you do. Right? You know you believe code must have bugs. I mean, when I write code, it has bugs. All code must have bugs. I don't want my expectation is that when you release code, you know it works. You know it works. You don't guess that it works. Has anybody done the guessing game? I think it works. The deadline's coming, man. Should we ship it? Well, I think it works. I mean, it worked yesterday on my laptop. When you release code, I expect that you will know that it works. You will know to the best of your ability to know. That may not be a perfect ability, but I want it to be the best of your ability to know that it works. When you release code, I expect that it will be as high a quality code as you can attain within the period of time necessary. I don't want you to just release things that you think sort of work. I don't want you to release things that you think are okay enough. It should be clean. It should be tested. It should be well organized. It should be good, solid code. And do you know who expects that? Everybody expects that, except you. Everybody does. If I buy a product from someone, I expect a high-quality product. If I am using a service from someone, I expect a high-quality service. I don't expect them to come to me and say, well, you know, there's always bugs. I buy a car from someone, right? I expect that car to work. I expect it to have been tested and put through the ringer. I expect that car to work, and I'm going to complain bitterly if even the smallest thing doesn't work. That's what all of our customers expect of us. I expect that we will always be ready. Now, what does this mean? Who's doing Agile? Look at the hands go up. You're all doing Agile. Want to bet? You have an iteration size. The sprint length. What's the length of your sprint? 2 weeks? Who's got 2 weeks? Anybody got longer? Who's got longer than 2? 3. 3. Who's got longer than 3? Who's got shorter than 2? Anybody got 1? 1 week? 1 week. What do you got back there? 1 week. 1 week. That's good. The programmers for the Mercury space capsule, the avionics software in the Mercury space capsule, had an iteration length of 1 day. They wrote their unit tests in the morning and they made them pass in the afternoon. We are now satisfied with an iteration length of 2 weeks. Okay, 2 weeks is probably not too bad. I like 1 week better. A lot can go wrong in 2 weeks. So I like 1 week, but okay, 2 weeks, fine. That means that I want to be ready to deploy every 2 weeks. Now, what do I mean by ready to deploy? I mean that from your point of view, from the technical point of view, the system is ready to deploy. It may not have enough features to deploy. That is a business decision. From a technical point of view, it is ready to deploy every 2 weeks. Okay, you can log out, but you can't log in. But log out works, right? And you're ready to deploy it. If the business comes to you and says, hey, can we deploy? You say, yeah, can't log in, you can log out, but deploy it. Because it'll work. That's what I want. And what does it mean to be ready to deploy? It means that all the testing is done, that all the documentation is done, everything for the current set of features is done every 2 weeks. Now, if you're doing Agile, you already know this, because what is supposed to be done at the end of the sprint? What should the state of the system be at the end of every sprint? If you are doing Agile, if you've been studying Scrum, shippable, deployable, deliverable. That's exactly right. So, if you are not deployable at the end of every sprint, you are not doing Agile. You're doing something else, not Agile. In Agile, you are ready to deploy at the end of every sprint. And that is not too big an expectation. I should be able to expect that. I should be able to expect that you will work for 2 weeks, and at the end of that 2 weeks, we'll have a system that is ready to deploy, even if it is still under-featured. That's fine. Does anybody here have a burn-in period? A stabilization period? You know what this is, right? You've got the release already. The code is all ready for the release. QA says it works and everything. And then you put it in a system, and you turn that system on, but it's not connected to anybody. And then you watch it for a long time. It's not smoking. Looks like it's still working. You know, like maybe if we let it work like this for another month, we could ship it. This is irresponsible. Time executed here does not tell you that the system is stable. You should already know that the system is stable. You should have the suite of tests that shows you that the system is stable. That little burn-in period is a false hope. Oh, if it runs for a month, then it's probably okay. No, it's not. You should be ready every 2 weeks, or 1 week. That'd be even better. I expect stable productivity. What does that mean? It means that the longer the project goes, the slower you don't get. You do not slow down as the system gets older. You are able to produce features at the same rate at the beginning of the project and at the end of the project and in the middle of the project. The feature production rate does not slow down. You are stably productive. This is a reasonable thing to expect. The rest of the world expects this. Adding new features to a system should not cause you to slow down. The reason we slow down, and I told you this before, is because we make a mess. And as the mess builds, we get slower and slower and slower. I don't expect the mess. I don't expect that we are going to get slower and slower and slower as we move forward. How slow can you get? Yeah, that's the right answer. Pretty damn slow. Pretty damn slow. I worked for a company once, and the minimum estimate for anything, didn't matter what it was 6 months. Changed the name of one menu item, 6 months. And there was a good reason for this. And the reason was that the programmers had been so badly burned by missing estimates, and the cost of missing estimates to them, personally and professionally, was so high that they simply refused any estimate lower than 6 months. They simply wouldn't do it. Also, the system was so badly coupled that changing the name of a menu item was liable to break something somewhere, because we actually had other systems that read our menus. Yeah, talk about a mess. And so anything that happened to that system was 6 months. I expect inexpensive adaptability. It should be cheap and easy to make changes to the system. Inexpensive adaptability. It should not be expensive for me to make a change. Or rather, I should say that the cost of the change should be proportional to the scope of the change. If it's a big change, it's probably going to cost a lot. If it's a small change, it shouldn't cost very much. That's what I expect. I do not expect you to say, when I come up with a small change from a customer, I do not expect you to say, oh God, that destroys our entire architecture. It ruins our whole design. You don't understand. We're going to have to reroute all the communication in the system to do this. I don't expect to hear that. Why? Software is a compound word. First word is soft. Second word is ware. The word ware means product. The word soft means soft. Changeable. Software means changeable product. Software was invented so that we could easily change the behavior of our machines. Had we not wanted to change the behavior of our machines, we would have stayed with hardware. But we did not stay with hardware. We wanted our machines to be easily changeable, and so we invented software. To the extent that your software is hard to change, you have simply reinvented hardware. You have thwarted the very reason that software exists. If someone comes to me and says, that change to the requirements thwarts our architecture, my response is, well, your architecture sucks, because you have thwarted the very reason that we invented software in the first place. Your software must be changeable. I expect inexpensive adaptability. How do you get changeable software? Well, you keep it damn clean, for one thing. Number two, you better have a really good suite of tests. Because when you change one part of the code, I don't expect another part to break. I want you to be able to change the code at will. I expect, well, that is an expectation that's coming. Continuous improvement. I expect continuous improvement. Of what? Of the system, of the code. The code should be getting better with time, not worse. The code should not be degrading or rotting. The code should be getting better with time because we are human beings. That's what human beings do. Human beings improve situations with time. They don't degrade situations with time. Human beings are not bacteria. We don't rot things. We improve things. But most of the time our code rots. I don't expect that. I expect the code to get better with time. Every day the code gets a little bit better. I expect the design of the systems to get better with time, the architecture of the systems to get better with time, because I expect that there's a group of highly competent people working inside that system, improving it continuously. That is a reasonable expectation for me to have, and it is the expectation that the entire world has of us. I expect fearless competence. Fearless competence. You're staring at your screen. There's code on your screen. Somebody else wrote it. As you bring this code up on your screen, the blood drains from your face. Oh, God. This code is a mess. And you think briefly in your mind, the thought strays in, maybe I should clean it. And the next thought overrides it immediately. I'm not touching it. Because you know if you touch it, you will break it. And if you break it, it becomes yours. So you walk away. I'm not going to be the one to clean this code. Somebody else can clean this code, but not me. I submit to you that if that is your reaction to the code, the only thing that can happen to that code is that it must rot. Because you will change it from time to time, but you will change it in a way to minimize your personal risk, not to improve the overall structure of the software. You will change it to minimize your personal risk, and that will always be the wrong choice for the system. The system will simply rot, and no one will ever clean it. It will get worse and worse with time, and the whole team will slow down by a factor of 10 or 20 over a period of 2 years. I don't expect that. I expect fearless competence. I don't expect the fear. I don't want you to be afraid of the code. Are you afraid to touch the code? Are you afraid to improve the code? Do you have that little echo in your ear saying, if it ain't broke, don't fix it? I expect you to improve the code all the time. Fearless competence. How do you get fearless competence? Tests. What if I had a button, a little button I could push on my keyboard, and some lights would blink and science fiction sounds would come out of my laptop for a few minutes, and then a little green light would light up. And that green light told me that the system worked, and I believed it. Given that, little light, and I believe it. I look at my screen, it's a mess. I think, I should clean it. And my next thought is, I think I'll change the name of that variable. Push the button. Oh yeah, green, good. That function is a little too big. I think I'll split it in half. Push the button. Green, good, didn't break it. Okay, I'm gonna move this function over into that class over there. Push the button. Red, put it back. Push the button. Green, good. I see. Put it over here. Push the button. Green. If you had that button, and if you believed it, you could clean the code. You would clean the code. It would be trivial to clean the code. You wouldn't have to spend much time at it either. You could just say, well, you know, I'll spend 5 minutes cleaning up the code a little bit, push the button a few times, do a little bit of cleanup, check it in, just a little better than it was before. And everybody could do the same little dance, check it in, just a little bit better than before. We call this the Boy Scout rule. Check it in a little bit better than you found it. Always check the code in a little better than you checked it out. If you had the tests, and if you believed them. If you react in fear, you become fearfully incompetent. If you conquer the fear with tests, you become fearlessly competent. You keep control over the code. I want you to think about how wildly irresponsible it is to fear what you have created, to respond to it, to react to it, to allow it to master you instead of you mastering it. And would it be that hard to make that suite of tests? Yes. Do I want you to write unit tests for code that other people have written? First, I want you to write unit tests for code you have written. Conquer that problem first. Okay?
That's the easy part.
Is that the easy part, really? Who's doing that right now? Testing every single line of code that they write. Okay, that's not a lot of people, so this is not the easy part. Let's get that one done first. Then we can talk about the code that other people write. And do I want you to write unit tests for that code too? Yeah, of course I do. I want you to write tests for every bit of the code. I want the code to be tested. I want you to have that button. I've got that button. The systems I write, I've got that button. I can push that button and I have absolute control over that code. I can do anything to that code I want. And I can do it fearlessly because I know from step to step to step I haven't broken anything. When you experience that for the first time, it will knock your socks off. You mean I can change this thing? It is a remarkable experience. There will be more to say about that in the next hour, but yes, go ahead.
I've seen sometimes that people write unit tests that are tightly coupled to the project.
Yes?
Because they had to have coverage.
Yes?
They use things like Mockito.
Yes?
Exact practical execution. And that these tests, if you change anything, even the behavior of the external behavior of the software, the unit test fails. This is absolutely useless. Because that actually creates more fear. You change refactor anything, you have to fix all the broken unit tests that are absolutely useless.
Yes.
So that's something.
Is that a question?
I mean, it's more like a comment, but having a unit test doesn't fix the fear factor.
So the question was, he has seen over the years that unit tests can be created so coupled to the system that if you change anything in the system, a whole bunch of tests break. This is called the fragile test problem. The fragile test problem is a problem that is experienced by people who are new to test-driven development. If you have only been doing test-driven development for a year or two, you are very likely to come across the fragile test problem. And the reason that you come across it is you have not yet realized that tests are part of the system and have to be designed as part of the system. They cannot simply be thrown in there as a bunch of tests. Tests are an integral part of the system that must be designed with all the same rules that we've always used to design any part of the system. So let me explain what I mean by that. If there is a part of the system over here and another part over here, they're not tests, they're just parts of the system, and you make a change over here and it breaks 1,000 things over here, what can you say about the design of that system? It sucks. Yeah, it's a terrible design. That's by the definition of bad design. The definition of bad design is when you make a change in one place and 1,000 things break in another. Well, okay, now turn these into tests. You make a change over there and 1,000 tests break, you got a bad design. How do you fix that? Well, you design the tests. You isolate the tests from the system. You decouple the tests from the system. You build APIs for the tests. You use all the same techniques that you use for normal system design for the tests. And you wind up with tests that don't break that way. Now, I'm not going to go further with that, although you did say one very scary thing to me, and I will harp on that for a moment. Is anybody measuring code coverage? Oh, yeah, good. Okay. Do you have a target number? What's the target number? 85. So it's okay if 15% of the code doesn't work. Right? There is no target number that makes any sense other than 100%. Right? You can't go around and say, we've got 80% code coverage. Well, I guess 20% doesn't work then. The only target that makes any sense at all is 100%, and you cannot achieve it. You can't get to 100%, so you have to look at it as an asymptotic goal, a goal that you keep on trying. It's like losing weight, I keep on trying. Sometimes I lose a pound or two. Okay, so it's very much like that. You keep on working to whittle that code coverage down, but you'll never get to 100%. Number 2, don't let managers see that number ever. It is not a management metric. Managers don't understand what the metric means. Code coverage doesn't mean anything outside of the context of the team. The team understands what it means. The team knows that those are the lines of code that are executed, and the team understands how many asserts are in the tests. If you make this a management metric, and by God help you, if you actually put it in the build and fail the build if you don't meet the number, then what happens is the programmers, in order to make the number, will start pulling asserts out of the tests. And the tests will become meaningless, and the code coverage number will shoot through the sky. You can get 100% that way. Don't do that. This is not a management metric. It's a team metric. It's a personal introspection metric. You get the coverage of the code that you are working on. The team gets the coverage of the code they are working on. They look at it privately. They assess what it means in the context of the system, and they act accordingly. But they don't publish the number, and it is not a goal. Sorry, that was a rant. I expect that we will not dump on QA. All right, I'm going to get that off the screen. This is disgusting. I expect that we will not dump on QA. QA is not the group that finds bugs. Did I miss one? Oh. Extreme quality. Okay, good. They're all part of the same thing. I expect that we will not dump on QA. QA is not the tool we are going to use to find bugs in our system. QA should find nothing. Do you have a QA group? You use QA? Who uses QA? Oh, some people do. Good. Why do we have QA departments? What would motivate a company to invest in a separate group whose job it is to detect whether or not the developers had done their jobs? Apparently the developers hadn't done their jobs. Right? Why would a company create a QA group? Well, because they got burned so badly by not having one. Why did they get burned badly? Because the developers didn't do their jobs. It's the developers' jobs to make sure the system works. QA can serve a useful function, that's fine, but the function they should serve is not at the back end of the process waiting for the load to be delivered. The function of QA is to specify how the system ought to behave. QA people have been telling us this for decades. Nobody pays any attention to them. Right? We don't want a bunch of people at the back end running tests, executing tests like they are computers. We don't want a bunch of people back there, Has anybody looked at a manual test plan? You know what kind of hell that is? Enter XYZZY into the password field. Click OK. Did the login screen come up? Check here. Yes, this is your job for the rest of your life. Right? That's awful. And by the way, what happens to QA? Do you think the beast actually delivers the load on time? Do you think that developers give the QA folks enough time to actually test the system? Hell no. Do you think the date changes just because QA doesn't have enough time to run all their tests? No. So who's under the most pressure in this environment? What team is under the most stress, the most pressure to get something done? And it's always QA. They're always sitting at the end. They're always under hellish pressure. And in that context, we're going to guarantee quality. It's absurd. QA doesn't belong at the end of the process. QA belongs at the beginning of the process. Developers guarantee quality of their code, not QA. QA should find nothing. The QA tests should find nothing. You release a system, you hand it off to QA, you expect them to find nothing. If they find something, your reaction ought to be, how the hell did that get loose? How the hell did that bug get through there? We got to do something to prevent that again, because we never want QA to find it. QA should wonder why the heck they're stuck at the end of the process, because they want to go to the beginning of the process anyway. And how do you do that? Well, I expect automation, test automation. Every test in the system should be automated. Every QA test should be automated. If a computer can do it, a computer should do it. If the manual test, if you've got a batch of manual tests, I expect them to be automated. Because, look, we're programmers. That's what we do. We automate stuff. And you say, well, it'd be very expensive to automate the test. No, it's expensive to run the test. You see this picture here? The hands there are the hands of the QA manager. The year is 2008. He's holding out to me the table of contents. For his manual test plan. He has 80,000 manual tests that he must run once every 6 months. He sends it off to an army of testers in India. It costs him $1 million every 6 months to run that suite of QA tests. He's holding it out to me because the year is 2008. The financial crisis has become. His boss has just come back from the CFO's office telling him that his budget is being cut by 50%. He's holding this out to me, asking me which half of these tests he shouldn't run. I told him, you can cut the document this way or that way. You're not going to know if half your system works. This is the inevitable result of manual testing. Manual testing always leads to losing the tests. You will either lose them this way, the big glaring way when some accountant finally says this is too damned expensive, or you will lose them in a much more insidious way. And the insidious way is this. The QA group doesn't have enough time to finish their tests because the developers are late. And the QA group now has to figure out which tests to run. I'm seeing myself on that screen. I did not expect to see myself on that screen. Oh, geez, it's following me. The QA group, now I'm distracted. The QA group has to decide which tests to run to cover the changes. So they look at the changes that were made, and then they make a guess about which tests they ought to run. They do an impact analysis, and they discard the rest of the tests. If the programmers knew they were doing that, the programmers would tap them on the shoulder and say, you really need to run all the tests? Because, we changed virtually every line of code in the system. One way or another, if you're doing manual tests, you will lose those tests. There is a disease that infects software development organizations, and it's a very interesting disease. How do you know if QA is doing a good job? If you're managing the QA team, how do you know that they're doing a good job? What metric could you use?
Feedback from end users.
You could what?
Feedback from end users.
Oh, yeah, get complaints from the end users. Yes. Defects, right? The number of defects that got through QA. Or regression testing time. How long does it take to do the regression test? Well, if it's manual, it's going to take a hell of a long time. QA should be finding defects. If QA finds a lot of defects, they must be doing a good job. This puts a positive value on defects. Someone now values defects. QA would like to have defects because they can now announce that they found them, and that's good for them. Now, who else wants defects? There's an old rule in programming, right? I can meet any schedule you set for me if the code doesn't have to work. Name the date, I'll be there. Now, that's interesting, right? Because that implies that if there are enough defects, I can meet the schedule. Programmers who are under schedule pressure love defects, especially if they can shuttle them off to QA. And QA loves the defects, because then they can say, hey, look at the defects we found. No one has to say a word, but the economy of defects gets set up. Both sides love the defects, and nobody knows this trading is going on. I expect, as your new CTO, that we will cover for each other. We will behave like a team. How does a team behave? You got a team of people. They're moving a ball down the field. And as they're passing the ball back and forth and moving it down the field, one of the players trips and falls down. No flag is pulled on the play. The play continues. What do the other players do? They cover the hole. They change their field position. They keep the ball moving down the field. That's how a team behaves. Teams cover for each other when a player goes down. If you are in a software team, you should be able to cover for each other. If somebody goes down, and people go down on software teams all the time, if somebody goes down, somebody else needs to be able to step into that role. How do you make sure that someone can cover for you? It is your responsibility. If you go down, someone should be able to cover for you. How do you ensure that someone can cover for you? Well, it would be really helpful if you sat them down at your terminal, at your screen, and walked them through what you were doing. You could do this by pairing. Remember, I get back to pairing, didn't I? You can do this by pairing. This is the reason that we want to see people pairing. We want people pairing so that we know they can cover for each other. It's your responsibility to make sure that someone can cover for you, so you will invite people to pair with you so that they can learn what your source files look like and where you keep them, what your make scripts are, and how you deal with Git and all that stuff. So that if you go down, somebody can step in and say, yeah, okay, I can take over. Has anybody worked in a team where Bob was the database guy and Bob went down and nothing happened on the database for a month? Oh, I don't know anything about the database. That's Bob. This is stupid, right? We're a bunch of programmers. We know how to do this stuff. We just need to cover for each other. We need to behave like a team. Teams cover for each other. I expect that. I expect that if I've got a team of 15 people and I decide I need to divide that team in half and take 7 people that way and 8 people that way, the 8 people remaining will still be able to operate because they know enough about the whole system to continue behaving like a team. That means they're going to have to share an awful lot of knowledge, probably by pairing. So let's talk about this pairing thing for a bit. People get very scared of pair programming because they think they don't want to sit next to some guy forever. Yeah, that'd be awful. What if he's got bad breath or something? It's always a good idea to keep some breath mints in your pocket just in case, but okay. I don't want you to pair 100% of the time. I don't want you to pair 50% of the time. I want you to pair enough so that you can cover for each other and that you can review each other's code. How long should you pair? An hour. Half an hour, something like that. Pair for, a few times a week. Pair for an hour, hour and a half, something like that. Maybe a couple of times a week. Just enough so that you have enough knowledge to cover for each other and that you're reviewing each other's code. I also think you ought to pair with lots of multiple people. So people should pair on the work that you're doing, and you should pair on the work that other people are doing on a relatively regular basis. And this should all be very informal. I don't want some manager putting a big chart on the wall saying, today Bob will pair with Bill. That's a stupid thing to do. Just everybody ought to be able to, from time to time, say, you know what, I'd like to work with you for a half an hour, and we can kind of learn what each other are doing. That's a wise thing for a team to do. And if you did that, you could probably eliminate most of the code reviews you do, because pairing is a much better way to review code. So keep that in mind. I expect honest estimates. What is the most honest estimate you can tell me? 3 little words, I don't know. That is the most honest estimate you've got, because you don't know. Right? Anybody who pretends they know how long something's going to take is lying. And by the way, if you make an estimate of a date, you are lying. If someone comes to you and says, can you get this done by Tuesday? And you say yes, you are lying. You don't know that you can get it done by Tuesday. Unless you're absolutely certain for some reason. Maybe it's a one-line change and Tuesday is 8 weeks away. That would be an interesting week, wouldn't it? So how do we deal with this? Because the answer, I don't know, is the right answer, but it doesn't contain enough information. Managers are going to need something better than that because they have to be able to manage. You know, managers have to manage things. So what can we do? Well, what we can do about this is we can define the shape of what we don't know. We can put a boundary around what we don't know. And to do that is actually very simple. This is an old idea. It goes way back to the 1950s. It was called PERT, Project Evaluation in Real Time. It was used on the Minuteman missile system. It was very successful. Old idea, great idea. And the estimation part works like this. You don't give an estimate of one number. You give an estimate of 3 numbers. The first number is the best case. Someone says, okay, here's this task, and you have to estimate it, and you say, well, okay, if everything goes right, and I mean everything, you know, you eat the right breakfast cereal every morning, every day you go to work, your coworkers are actually polite to you, you watch the right TV shows at night, you get solid 8 hours of sleep every evening, all that stuff, right? Everything goes right. It's going to take me a week. Then the next number is the nominal case. This is when things go the way they usually go. Okay, if things go the way they usually go, I'm going to spend half my time in meetings and arguing with my coworkers, and my wife and I are going to get into a fight half the time and won't be useful for coding for a few days, and it's probably going to take me 3 weeks. And then the last number is the worst case. The worst case is everything short of nuclear war, right? Everything goes wrong, right? There's production outages every day, and they take you all day long to fix. And your coworkers are rude, and they're throwing spitballs at you, and half of them are sick, and you have to deal with all their crap anyway. And you say, okay, if that happens, it's going to be 8 weeks. 1 week, 3 weeks, 8 weeks. That's a really honest answer. It's probably right. Now, no manager wants to hear that, by the way. Right. Because manager wants a number. Give me a number. No, I can't. I can give you 3. No, I want a number. No, I can give you 3. I can't give you one number. I'd have to lie. And I don't want to lie. I'm going to give you 3 numbers. And then because you're giving them 3 numbers, the managers have to do something that, well, I hope they're used to doing. They have to manage. Because the job of a manager is to manage that kind of risk. Now, of course, they'd like to limit that risk as much as possible by making you absorb it, but you must not absorb it if you don't know you can make it. What's that? Time for a break. Okay. Yes, it's 3:15. Good. It's time for a break.